Good afternoon. You're back for some more. Today we're going to look at lesson 1-3, and it's all about taking a guess. So we're going to do some estimation. We're going to learn about some inequalities, and estimating and taking educated guesses is really important to be confident to do in life. Like when I'm shopping, I do some estimation just to see if things seem to make sense or if I'm going to have enough in my budget to spend on those items and such. And so these are important things. And I'm going to share my screen with you all so that you can see what I'm working on today. So I'd like you to go through. Michael Jordan has a famous quote here: "Don't be afraid to fail, be afraid not to try." And that is very important. It's very important to give things a try. And if they don't turn out the way you wanted the first time, it's okay. You can try again. So after a bunch of years, I decided to go back and get a new degree, and that's when I became a math instructor. So it's never too late. Okay, so where we're going to start is on the bottom of page 40. They kind of talk about Polya's 4-step procedure for solving problems. You need to understand the problem, write it down, do some underlining, highlighting as you go, devise a plan to solve the problem, carry out your plan to solve the problem, and then check your answer. So the first thing we're going to work on today is estimation. And it looks like we have a timeline here. So it says the number line is a timeline of important advances in medical science, and we're going to use it to answer questions 3 through 7. And so it looks like this starts in the year 1500 and goes all the way through the year 2100, which we're not there yet, right? We're right about here. And it looks like the dashes in between, if these go by hundreds, they should go by 50s in between. So this would be like 1750. This would be 1950, so it'd be 2050, right? Okay, so we're going to keep this handy. So question 3 says, estimate the year that the microscope was invented and describe how you got your answer. So I'm going to look for microscope, and there it is. It's the one furthest to the left. And like we said, this in the middle here is 1550. And so there's 50 years between 1550 and 1600. And so if I broke these into 5 spaces, 1, 2, 3, 4, 5 spaces, I would say those would each be 10 years, right? And the microscope was invented before 1600. So I'd say it's in between 1590 and 1600. So I'm going to say 1595. That's the year I'm going to choose. Yours was probably somewhere around there. Estimate the year that germs were identified as the cause of disease and describe how you got your answer. Germs identified as the cause of disease. Okay. So again, we already know that this is 1850. And again, there's 5 in between there. They each represent 10. So I think that's pretty close to 1860. Which happened first, the first test tube baby or the first heart transplant? Test tube baby or heart transplant? It looks like the heart transplant because it's to the left. Heart transplant because it is to the left. The heart transplant was to the left of the test tube. Which happened first, organs grown from stem cells or the identification of HIV? There's HIV and there's organs grown from stem cells. So it looks like HIV. HIV. Oh, and it said estimate the year for each up here. I didn't do that. So the test tube baby, I would say is maybe maybe 1970. And the heart transplant, but that's 1950, I'd say maybe 1965. And then organs grown from stem cells. Ooh. I'd say maybe 2019. And the identification of HIV. Oh, so 1950 was here. I would say that was right around 1980. And it's definitely after the first test tube baby. And I said that was 1970. So I'm going to say this is 1980. Okay, we learned a lot there. So one other thing we're going to use a lot in this class is comparing numbers. One number to another, one is bigger than another, one is smaller. So you can see in this table, they go through, this is a not equal to symbol. 10 is less than 12. 10 is less than 12. So 10 is to the left of 12. You did a nice job of explaining that. Y is less than or equal to 10. So the item that's less than has the arrow pointing to it, and it's open. It's always open to the bigger number, like an alligator. I never really thought of it like that, but I had a student explain it, and it made so much sense. Use your answer from question 5 to write an inequality involving less than that compares the dates for advances mentioned in that question. So question 5 was which came first. So I said that heart transplant came before the first test tube baby. So heart was less than the first test tube baby. Okay. Use your answer from question 6 to write an inequality involving greater than. Okay. So I said HIV came first and then the organs. So it would have to be organs was greater than, the date was greater than, right? So organs from stem cells is bigger than HIV identification. The two most recent events on the timeline are organs grown from stem cells and skin cells grown into stem cells. How do the dates compare? And it looks like the organs grown from stem cells came just before the skin cells used to grow. So organs from stem cells is less than skin cells used to grow stem cells. Okay, so it says your first instinct might be that growing stem cells from skin cells came later because the words are set farther right, but their position on the graph indicates that they might have also occurred in the same year. When comparing two quantities that may be equal, we can use the sum there. So yeah, we could have done that possibly. They do look like they're very, very close to being on the same year. Use one of the symbols introduced in the previous paragraph to describe the relationship between the dates for organs being grown from stem cells and stem cells being grown from skin cells. Do so using verbal descriptions of those quantities first, then assign a letter to represent each quantity and write a second inequality with your variables. Oh gosh. So organs from stem cells and skin cells from stems used to grow stem cells. So I'm going to say O and S. So I'm going to say this. And it appears that organs from stem cells happened before or in the same year as skin cells to grow stem cells. Okay. Question 11 says, estimate the monthly cost of homeowners insurance. So we've got a new graph here. We're looking at cost per month, cost of homeowners insurance in different states, Arizona, California, Florida, Hawaii, and Texas. Estimate the monthly cost of homeowners insurance in California. So it looks like it's right about 80. Do you think your estimate may be too high or too low? Why? And I said too low because I think it actually is a little bit above the 80 mark. Using your answers to questions 11 and 12, write an inequality using either greater than or equal to or less than or equal to that describes the cost of homeowners insurance in California. Use letter C to represent the cost. So I said C for the cost in California is greater than or equal to 80. Because I think it probably is. It looks like it's just above that. Suppose that you were planning a move to Arizona and wanted to budget a monthly amount for homeowners insurance. Would you prefer an overestimate or an underestimate? Explain. Wow. I would prefer an overestimate so that if it ends up being lower, I have extra money in my budget. If I budget too low and it ends up being higher, I'm going to be frustrated that I didn't allow money in my budget to pay for that. That's just how I think. What estimate would you use for the monthly cost of homeowners insurance in Arizona? And so it looks like it's just under 60, but I would approximate it at $60. Okay. So they do a nice job here of giving some good verbal descriptions of the less than, the greater than, less than or equal to, or greater than or equal to. And these are good, these are funny ones here. So on 16 through 19, it says, write the statement as an inequality, then give an example of an actual value that would match each description and satisfy the inequality. Then give an example of a value that satisfies the inequality, but doesn't make sense in the context of the situation. So it says we can fit at most 12 people on the slow ride pedal bus. So I'm going to say P for people has to be less than or equal to 12 because it says at most. And our little table here says at most is a less than or equal to. So we could have 10 people, right? Because that's less than or equal to 12. Then give an example of a value that satisfies inequality but doesn't make sense. So I could have a -1 is less than or equal to 12, but you can't have negative people. So that one doesn't make sense. It's estimated that there are at least 50 ways to leave your lover. So at least 50 on our chart is a greater than or equal to. So leaving my lover is going to be L, and it's greater than or equal to 50. And I could have 75 is greater than or equal to 50. And then a number that satisfies it but doesn't really make sense is a million ways to leave your lover, maybe. That's kind of a weird one. What about 18? It says, I get a text alert from my bank if the balance in my checking account drops below $100. Okay, so I'm going to say C for checking drops below. So if it's less than 100, and then 50 is less than 100, right? And a number that's less than 100 that wouldn't make sense. Well, this would be real bad. And it kind of does make sense, right? You could -10. It is less than 100. And it does make sense, but you don't want that to happen because that means you actually owe the bank some money. So that would not be good. Any amendment to the U.S. Constitution will only be enacted if more than 37 states vote to accept it. Okay, so let's say states, we'll call this S. Only if more than 37. So we have to have greater than 37. And if 48 states, that's okay to use, right? 48 states is more than 37, so that would work. And we could say 60 is greater than 37, but 60 doesn't work as far as a legitimate number because we only have 50 states. Okay. The last little section is doing some more estimating, but this is on an isotherm. So an isotherm is a curve on a map that connects locations where the temperature is the same. By looking at a large map with isotherms, you can get a rough idea of what the temperature is like in many different locations. Using the map, estimate the temperature in each city. So you can see Las Vegas is the letter L. And that one falls right on the isotherm value of 40 degrees. Some of these fall in between. So you can see that just because Maine is north of, let's pick another one here. Just because New York, the state, is north of, let's say Missouri here, Iowa, Missouri, I guess this would be, Nebraska, Colorado. Oh my gosh, I got my states mixed up. Doesn't necessarily mean that it's colder because you can see the way the wind currents go. That's why they kind of move like this. So let's do some estimating. For Phoenix, P is between 40 and 50. But it looks like it's closer to the 50. So I'm going to say that one is about 48 degrees. Dallas, Texas is D, and that's down here. And that is between 20 and 30. I'd say right in between. So I'm going to say 25. Springfield, Illinois, S is between 0 and 10. And it looks like it's closer to the 10. I'm going to say that's 8. Atlanta, Georgia is A, and that's between 30 and 40, closer to the 30s. So I would say maybe 33. Miami, Florida is M, and that's just below the 50. I would say that's a 53. And New York is N, and that's between the -10 and 0, and it's close to 0. So I'd say maybe at -2. And then there are these estimating ones that I said pick one between 8 and 12. And I'm going to do how much money are you completely wasting every time you skip a college class? What information would you need to calculate this exactly? So I'm just going to kind of go over the idea of estimating is thinking about what all goes into this. So we need to know what is the cost per class, which you need to know the cost per credit hour, right? How many credit hours is the course? Okay. Every time you skip a class, so how many hours does the class meet? How many minutes or what hours, right? How many minutes does the class meet? And then are there other fees? Because I know schools charge other fees for things too. So you would need to know those things, right, to kind of figure this out. So some things to think about. And that concludes, oh, no, there was an estimating here in the application section. I wanted you to do some estimating on going to the store. So it said shopping provides a really good example of the value of estimation. Most people have a rough idea of how much they have to spend in a given shopping trip. While you pull out your old cell phone calculator and add up all of your purchases to the cent, who has time for that? Instead, it's helpful to round prices to easy to use numbers and keep rough track of the total. Use this idea to estimate the total cost of each group of items. Round each price to the nearest dollar, then try to estimate the overall cost in your head. So we have 4 boxes, and if we rounded that up to $1, really 90 cents, right? That would be $4 total. And a gallon of orange juice, if we round that from $3.79 to $4. A loaf of bread, $1.79. We could round that to $2. And 2 pounds of ground turkey at $2.97 per pound. So we have 2 times, I'm going to round that to $3 per pound. So that would be 6. So this would be about $16, right? And it's always better to overestimate at the grocery store because you'd hate to underestimate and then discover that you don't have enough money. What about this one? 2 pairs of jeans, $24.95 and 32. So I would say round that one to 25 and round that one. I'd round it just to 33. A 3-pack of socks is $7.99, so that's 8. And 3 workout shirts at $11.99 each. So we're going to say they're each 12. So 3 at 12. So those total 36. And then my 2 pair of jeans total 58. So we have 58, 8, and 36. So 66. So about $102 for the clothes shopping trip. And that sums up the gist of what we worked on for lesson 1.3. And if you have any questions, catch me back, send me an email, reach out.